judging. But what I was going to say is because I had mentioned that I'd spill water when I was like in seventh grade, but on my lap. So, but anyway, the point I was going to make is I don't judge because lest thee be judged. Yes. And I do a lot of silly things. So. I'll give you plenty of opportunities to judge me over the years. But anyway, so we're gonna talk about database stuff today and SQL. There's no like easy way to describe this. We're gonna have to learn how to work with the database, and we're gonna go slowly because I'm gonna teach you as we go along. You're not expected to have known this already. Those of you that have 333 or some database experience before, all of this is going to be massively reviewed, and I'm just going to go slowly, so it's going to suck even more. Sorry. But for those of you that don't have it, this is going to become very important. One of the things we're going to encounter pretty quickly is we're going to have NetBeans. One of the benefits of NetBeans is we're going to actually have access to Derby database, and that gives us a tool to actually interact with the database using NetBeans directly, right? So you can actually see what's happening in the background. So when we talked about using Visual Studio or Eclipse and so forth, those are great, but you won't have access to some of the database stuff.
Is that bad?
No, you can run Derby without NetBeans, totally. It's Java. It's a Java database, right? You totally do it. It's just you won't have like I'm literally like if I don't have NetBeans open right now, but like if I open NetBeans, it takes a minute to open on my computer. I'm going to be able to work with the database directly. We're going to do that next class, and I'll show you how to do that. But in the meantime, I'm going to tell you about another thing that you probably all have or close to have, and most of you have Access, Microsoft Access. Most of the queries that we're going to do will work in Access as well. So if you're like, I don't understand how to do this query, once we get into NetBeans and we'll show you how to get into that database, then you can run the command right in there and so forth. But if you want to just figure out how that SQL command should work, you can type it in Access as well. So why do we employ databases in web applications to begin with? We'll talk about that. We're going to talk about several database management system concepts, including relational database management systems, tables, relationship, and use. You have a relationship without a table? You can have a table without a relationship. I'm dead serious. That's actual database management system thing. It sounds like I'm talking about real relationships. Actually, yeah. Anyway, sorry. We'll be talking about doing one for a web application. Web applications use databases in the backend, but fortunately, we don't do really, really hardcore complicated things because we don't generally need to. But they can get hurt, right? We'll talk a little bit about that as we go along. We're going to do field data types and their use. We'll talk about that really quickly. 90% of you are going to use the integers and strings and integers, strings. There's one more. Can't think of it. It's not doubles. We'll get to it when we get to it. Brain farting. Might be doubles actually, but anyway, we get some dates, but we won't probably use too many dates. Your project might want to use dates, and that's totally fine because dates make a lot of sense for a lot of things, right? But that is a field data type. But what I was thinking of is there's three basic ones everybody's going to use, right? And we'll get to it when we get to it. So again, it should be pretty basic. We'll talk about SQL in terms of use, purpose, and we'll discuss several SQL statements for such things as data manipulation and data definition. We have to define data before we can manipulate it, right? Yes. Why databases? Performance, right? You have thousands of people come into your website and they want to get access to stuff. If you have a file and everything's in a file, then it takes forever to read the file, right? It's one of the slowest things you can do. Database management systems actually are designed and organized to actually speed everything up. By design, they're designed to access information rather quickly. Security. We only want certain people looking at certain things. If we have to manage that security on our own, it can get complex pretty quickly, and we can have lots of issues. Database management systems are built with security in mind, so they typically require logins and those types of things. Integrity. Database management systems were developed with multiple users. So if Trisha's editing something that Riley's trying to read, and she finishes editing it, the database management system knows that both people are accessing it and can maybe inform him that the data is old, right? Or inform her that somebody else is reading it, right? Whatever. That's built for that in mind, right? You have to actually add a bunch of things to make integrity work in the real world. Access, standardized handling, accessing data, and it's designed to do it very, very quickly. I don't care about analysis, but like eventually you store everything in a database, right? Like Axios, those kind of guys store everything you do, every time you click on something, every time you do something is stored in a database. And then we can actually look at that data and try to determine trends and so forth. I don't care so much, but fact is that we can't get around databases. And the reason why is that we don't deal with files with 10 things, right? You don't have a website with just 10 things, right? You wish you had 10 users, right? You probably wouldn't need a website to manage something like 10 users. You could probably do a secretary and it can do it pretty much by itself, right? We need a database when we have millions of users, right? It'll handle millions of users just as well as it'll handle thousands of users. And you go, wait, what? Yeah. So imagine you have a million records, nothing more than users, and you want to store information about the users. So for instance, we want a username and password, right? And then we want a real name, right? And then we want an age and a credit card number, maybe, I don't know, right? Who knows? Right? Your database can have your things in it. My database has my things in it. That's like 10 pieces of information. It's not even that big, but millions of things. How do we access that quickly? Databases are built to do that. They use data structures underneath them that force that to work efficiently. Building this via hand is just not possible. That's why we use it. You know, the book, not the book. If you look at any book, they don't talk about this, but real systems will use real amounts of data, and the real amounts of data are hundreds of thousands of users, right? In some case, millions. When I used to work for the US Navy, right, we had naval recruit database. So, you know, we're only talking about 3,000 recruits at any given time, right? Right? It's not that many, except every day you have 3,000 or 4,000 recruits being added to the other system. Every day, right? You know, wait, what? Not every day. It's usually once a week. But the point is, it's a constant stream of people coming in, and they all have different numbers, ID numbers, and so forth. How do we keep all this data in mind, right? We have to use databases. There's no way to get around that. Now, we were joking, or not joking earlier, we were talking earlier about a user record, having a student name, having a credit card, blah, 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 because I'm thinking of DirecTV and Sunday Ticket, right? Sorry, football's right here around the corner. I'm excited for football. So, right, that's what I was thinking of. But with recruits, right, what do we actually have maintained data on them? Their medical history, their entire medical history, right? Their physical measurements, right? Height, weight, those type of things. If there are certain types of job requirements for a certain type of person, we see if those match those certain type of things, right? So like, there's not a really good one where it does physical characteristics, but like Navy SEALs might have screening where they try to get certain people with certain body mass indexes, as for example, hey, you should try out for the Navy SEALs, as an example. Bad example, but it is what it is. And so we have all this information about jobs they've applied for, all their information goes into a database, right? The records by themselves are quite large, as it turns out. And we had to process, I would say, about 2,000 or 3,000 of them. It was usually on Friday, but who's counting? I don't remember. Pretty sure it was a Friday. Almost certain it was a Friday. They finished recruiting, they finished their stuff on like the Great Lakes or at Orlando, whatever the basic training was. And then they would get their orders and so forth. But while their orders were being processed, their database transactions would go in, put them in. Their database would go from the recruit database system to the major, the employee system. I don't want to say it was the middle of the day Friday, but anyway, the point is there's too much data to just manage via file. So we have to use database management systems. When you think about Amazon, when you think about Google, well, Google is a special animal, but like when you think about Amazon and keeping track of the number of products, right? You ever search for something recently? Back scratcher, right? I word a back scratcher. I said back scratcher because Peter Griffin said back scratcher once, right? And it's stuck in my head. That's how you say it, right? Anyway, and looking for a back scratcher. 2,000, I think 2,700 back scratchers. And that, who knows if they're all back scratchers. Some of them could have been. A friend of mine says, doesn't matter what you search for, if you look at all the things on the Amazon list, eventually one of them will be a sex product, right? So I don't know if they're all back scratchers or combination thereof, but 2,700 results were returned, right? Look for something like a match, right? What's the joke? It's something about a lighter, right? You go look for a lighter, but all you found were matches, right? 20,000 things are returned, right? I don't care what you're looking for, right? Maybe not many of you were looking for back scratchers, right? Who knows what you're looking for, right? Shoes. I buy my shoes online. I buy my pants online. I bought shirts. I don't like to buy shirts on Amazon, but I have done it in the past, right? You ever notice that there are 30, 40,000 things for the specific thing? Like I'm looking for a light blue. What was it specifically? All right, so this is one with only a few results. I was looking for a light blue 17.5-inch neck, right? And what was it? 31, 32 arms. And what was it? I can try to think of the name of the shirt, French cuff, right? Very, very specific. And I still got 2,000 items returned, right? Super duper specific, right? Think about how many items they actually have. Billions of items. So there's no way to do any of this without a database. And that's just a reality. There's just the sheer amount of data, which means we're going to be interacting with databases. I don't care where you are, what you're doing, you're going to be dealing with databases. So what is it? Database is a collection of data. Database software is generally designed to help you find, organize, update, and report information in a database. What I want you to remember about a database management system is it's a set of tools that allow you to interact with your data. It manages your data, keeps it safe, right? Lets you get to it, lets you change it, right? Like it's magic. This. We don't have to go into the details of the fact that it uses a B tree for indexing. Do we care about that? Any of you know what a B tree is? It's an M-ary tree. You know what an M-ary tree is, right? You know what a binary tree is, right? How many trees is a binary tree? M-ary is the letter M means it's a variable. Did I do that? I did that right, yes. I was like, did I make an M? I think I made an M here. It's an M-ary tree, right? So it means it's like just thing, right? You're like, wait, what? If you go into dig deep enough about database management systems, you'll go into learning how they actually do indexing, how they actually store, how they actually make things efficient. We don't care. We just know that it is efficient, right? Do you care how power? You probably care a little bit about how power gets there, right? But you just care that it plugs in, right? When you got to charge your phone or charge your pen case, right? And the things that the technology today, right? There's a phone. My sister was trying to get she had to actually not get it because it isn't too big for her phone, too big for her, the place where she has to put it, but she has a refrigerator that actually remembers what's in there. Yeah, and she can go on her couch. This is why she wanted it. She can go on her couch and look at what's in the fridge.
Can you just open the fridge?
No, 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 no. But when you open the fridge, what happens? By default, you raise the temperature of the things in the fridge. The longer you have it open, blah, 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 blah. It's not energy efficient, right? Wow, right? Do we need that technology? Could you imagine how badly that could be misused? Right? Okay. So I don't know about you guys, but I was a hellion when I was little, right? Probably not you, but beer in the fridge, right? We never had beer in the fridge because my mom didn't drink, but and my mom was by herself. But imagine I had beer in the fridge. Yes? I went and stole a beer because, right? And then my mom could check from work. Oh, one of those, I don't know. I'm going to make up a, what is it? Milwaukee's Best is missing, right?
That's where I can see it being good. That's the only reason.
Is that really that good? Maybe you could check to see if your wife stole your leftovers, right? So when I was a kid, I used to go on dates a lot, and then I'd like to go to these places that would serve massive amounts of food, right? And so I'd always have leftovers for the next day. And so my mom and my sister would convene on like vultures onto my leftovers. So I could check my leftovers, right? We can do these things now that we didn't used to do. My sister actually has a home security system, which she could actually, I can because I used my phone to hook into it just to make sure it worked. But like I can look and see what the front of her house looks like, the side of her house and the back of her house. Right? I mean, even though I'm in Chicago, right? And you're like, wait, what? It's just an app on your phone that connects to a security system that connects to the internet. And that's just how that works, right? We have the access to these things, but in order to do these things, we need a lot of technology to make that happen. All right. So how do we actually make things efficient? Yes, you can go to the grocery shop. You can grocery shop, so you can make a list of things that you don't. Suppose Riley wants to make cookies, and he says, "Well, do we have butter in the fridge?" That's a good use case. I like that, Karen. But anyway, the point is we need technology to make this happen. Data organization. So we have to have data has to be organized, right? So what are things organized into? A field. That is the lowest level of item. We are going to say, let's say an ID, a name, something specific. That's what we refer to as a field. Usually it's a single data item. It can be employer ID, name, address, whatever. And then a record, sort of related thing. So if I have a record of, actually I'm trying to remember your name. I'm like falling blank. It is, it's got Drea as part of it. Andrea, right? Okay. I couldn't remember the first part. So suppose Andrea has an ID and a GPA and a name and all those things, right? All those together are related. How are they related? We'll talk a little bit more about that later, but they're related. So those are what we call a record. Those things go together. And then we have a table. These are a collection of records. We just talked about Andrea's record as a student. What if I wanted to have a table of all the students? And each row would be a record. That's how we actually store data in a database. Are you serious? No, mouse is working. So what? It is not. There we go. Here's your example. You have fields, employee ID, employer name, employer address, phone number. These are all fields in a database. Each record identifies a specific item, right? So employer ID 10122 is Beantown Tours. Beantown, must be bought. Yep. 105, the employer address is 105 State Street, Boston, Massachusetts, and the phone number is blah, blah, blah. Those all together are related. How are they related? Well, we have an ID that identifies all the other things, and the employee name employer address go together, the phone number and those things go together and so forth, right? Right. Set of all the records becomes a table. That's it. Pretty simple, right? Yes. Believe it or not, it's all this simple. There's really some caveats we throw in there, but it's all this simple. So a relational database is a collection of related tables. We have a table and then we decide to break the table into parts. You know, wait, what? Sometimes we have a school for information, for instance, and we have students, and students go to a school. Yes, but suppose I have a roster and it has the student name or student ID and then the instructor ID, right? In my roster. Do I need to have everything in the roster? Or just the ID, right? Wouldn't it make sense just to not to copy all that data and just copy the ID? And then I can reference it? That's creating a relationship between two tables. Yes, we do not want to have common fields. We actually don't ever want common fields, ever. Why? Because if I have data in two places, what happens when I go to update the data? I better do it in both places because otherwise we have inconsistent data. And what happens when we have inconsistent data? All hell breaks loose, like you don't get paid in February. For those who don't know, I didn't get paid in February. I'm going to remind you guys. No, they fixed it like mid-February, but they fixed it. No, they fixed it like a week later, but they fixed it. I was pretty pissed about it. It's life, right? Life in the fast lane, right? But anyway, that's what happens. It's inconsistent data in two places. And then it gets applied incorrectly, right? I was once, I have hospital, and I was about not at the hospital, but I'm paying a bill at the hospital, and they said, "Well, this is overdue by 6 months." I'm like, "Okay, so how much is it now?" And so, like, I had to pay some overage fee or whatever. And I was like, "Well, why didn't you guys send me a bill?" She looked at my address, and sure enough, she had an old address. Yes, I set up a forwarder, so if I get mail at that other address, it should go through. But for whatever reason, it wasn't going through. That's how things like this happen, right? If you update data one place and not two, right, becomes hell. So we never want to do that. So how do we deal with that? We deal with tables and then having the relationship be in place between the tables. So we're going to need to talk about a primary key. A primary key is a field or collection of fields in a record whose values uniquely define each record. So if you look back at our employer table, what field would we want to use as a primary key? What uniquely identifies things? The employer ID, right? Hopefully the employer ID is unique among all of these, right? They don't share those. But we could have a business with the same name. Suppose, apologize for any Bostonians. That's the right way to say that. But let's suppose Beantown Tours closes down. And then somebody comes along and says, you know what? Let's create another Beantown Tour, right? We could have a system where we have two different employer IDs because they're actually different employers with the same name. Yes, could totally happen. That's just an example. We deal with it all the time at school. Most of you guys, is there any obvious names? Juan, do you have like a 01, like 03? You might.
A 01.
Oh, yeah, see, okay. So the 01 after his name and his email address, it's J Sosa 02,
Yeah,
means there were two J Sosas before you. Yes? Now, if you get a nice John Smith in there, right? It could be J Smith 08 or 012, right? Or whatever. We had one that was like a 40 something. It was a Patel. I forget the first name. Something Patel, but it was like 40 something, like 42 or 43. Right? I don't remember the name. But the point is we get those. How do we deal with that in the email world? How do we make those emails unique? We add the 01, 02, and so forth. Your employee, not your employee date, your student numbers though, what they call them 900 numbers. They call them student IDs, right? Or do they call them 900 number, huh?
They usually say student ID.
Okay, so your student IDs, right? Those are actually meant to be unique. We're legally not allowed to identify you by your social security number. It's a law, it says we can't do that. So we have a student ID that's uniquely identifying you. That way we don't have to rely on JSOSA 04, JSOSA 06, right? Still, we have to do that with emails. And sorry for using you as an example. I was just thinking that JSOSA might be common, but no super obvious name, right? Like, you know what I mean? Every now and again, with a J Smith, right? I had another one. I'm trying to think of his name, something Jackson, and it was like it's 7 or 8 of them, you know. So whatever, it's interesting. But the primary key uniquely identifies it. Now, why is that important? Because if we put the primary key in a different table, that's how we reference the key in the other table, the primary key in the other table. And we call that a foreign key. Okay. So there's several types of relationships among tables. One to many, most common. So I have an advisor, right? Suppose you all have advisors, right? How many advisors do you have, Andrea? Yes. How many advisees do I have? Many, right? One to many, see? Now, I have how many offices? How many people are in that office? I'm gonna ignore that you said too many.
You don't count the students that come to your office?
I do not count the students that come to office because it is assigned to just me. How many people is it assigned to?
I'm gonna come there every time.
It's just me, right? So 1 to 1. I thought he meant too many, like too many that I'm just the one assigned to it. Like life would be so much better if you
Well,
weren't
wait,
actually
isn't your
there.
office
That's
shared
what-
with like 3 other people though?
No,
Like,
like
there's 3
the
different rooms in the office?
the inner space is shared, but not my office.
Your office is in a bigger office though, isn't it?
Yeah, and that part is shared.
Okay.
Just like this building is shared. Right?
Right.
Okay. So many to many. Here's another one. How many courses do you have? You have 5. So you have many, right?
Right.
And how many people are in each of your courses? Many, right? So many to many relationship, right? Go back to me, like make it all about me, right? I have many courses and I have many students in each course, right? Pretty normal. Yes. Those are the type of relationships. I don't care. Okay. But you aren't going to have to design massively complicated databases. Most of you will have a single table or a secondary table, right? With one foreign key from the primary table. Ta-da! Pretty simple. So primary key example, you have your employer ID, we talked about that, but then we have a position table. The position identifies positions like waiter, waitress, I can't read that, tour guide, host, hostess, lifeguard, pro shop clerk, kitchen help, whatever. Yes, you could use better kitchen help, right? Now, did you do this to yourself or did
So what I think happened is I'm pretty sure you pulled something out of the freezer that had a chunk of ice on it and then threw it in the fryer and didn't realize that the ice was water.
okay?
So it started kind of like erupting and I had to turn it off. So I was like pulling it from the
Yeah,
wall.
no, I get how bad things can happen. I had a friend who jerked because somebody was bumping him or something too close to the fryer and he stuck his finger in the fryer. So, yeah, I mean, injuries occur, right?
Does his hand look nasty now?
No, it looked funky, like it was burned,
No.
but it healed.
Yeah.
Like, looked funky when we were juniors and seniors, but by the time we were graduating, you know, underneath his hand, like on the bottom, like you can see like it's wrinklier than say my hand is, but it's not like melted off. You know what I mean? He didn't get Anakin Skywalker. I am the high ground, right? So he didn't get burned that bad. But anyway, okay, go back to our position table. You see the employer ID? That identifies the employer table, like where this position is. Yes? You guys are gonna have, we're gonna do students or employees for homework, I don't remember. We'll do something completely different. But anyway, the point is you'll have users at some point. You'll have login users, right? So username and password type things you have to remember. And then they'll be responsible for parts of the table, the main data that you're doing. For instance, students will have an advisor, and the people that log in will be advisors. Yes? So each student will need a advisor ID attached to it, and that'll reference the other advisors from the other table. Yes? That's about as complicated as yours is gonna be. All right, so a database management system is a software program that lets you create databases and then manipulate them. A relations one is one that stores information in tables, and Derby is a relational database management system. You have heard of NoSQL, you've heard of lots of other things like that. They exist. We do not have the time to go over every possible scenario, but we're going to use a relational database. So what do we do? What do we care about? We care about the creation of database structures. Why? Unfortunately, you're going to have to create database structures. They're going to be relatively simple, but you're going to have to create them. That means you're going to have to create fields, tables, and relationships between tables. Then you want to be able to easily add records, change field values, and get rid of records. How do we do that? We do all of these things with a built-in query language called SQL. That's what SQL stands for, Structured Query Language. We'll talk about that as well. And the other thing that database management systems have the responsibility for is protecting assets through security, right? They require login, they don't run, and then they require levels of support, levels of security. Now, for our purposes, we're going to allow users to do everything, right? Yes? But you could set up a situation where some things are visible to everyone and other things are visible to only the administrator and so forth. We don't want to care about that here because we don't have time. So what might you want to store in a database? Anything that might be obviously a large list of things that you want to keep track of. So for example, if you want to deal with appointments, such as my upcoming appointment with Dr. Fishbein, real name, allergist, my son's allergist, that we have on Friday, right? What do we have to know about a doctor appointment? Date, time, doctor, patient, right? And probably location. Is that what you were saying? Reason to visit. There you go. 6 things. That's a database record. Why not? Right? There you go. What about an appointment with me? Student, name, reason to visit, time, and date. Appointments always have the same, like generally speaking, appointments are the same thing, right? What about you want to, when Karen was talking about having to go to the grocery? Yes, I have to go to Home Depot this week, probably today, and I have to get polyurethane. I have to get paint. Trying to think of the name of the paint. It's a weird name. But it matches IKEA's black brown finish. I'm sorry. And that's what it does. And then I'm going to get some paintbrushes, right? I have a shopping list. It's a pretty simplistic list. Now imagine I'm going to do it for hundreds of people. That's still something I would want to manage in a database. Yes? Customer records, we're going to do employees, students, those type of things, or something completely different for homework. Yes? So for instance, student records, obviously, you have employee records, obviously, or maybe you have blog posts, right? Things that you might want to keep. And specialized user accounts. What is a specialized user account? At a minimum, what's a user account? A way to log in, right? Assuming we're thinking computer system. So you got to have Ruth, and then you got to have my password, which I'm not telling you, right? For those that didn't know, I stuck my tongue out or when I said I'm not telling her. Anyway, then you might have access controls. We'll talk about that later when we get there, but you might have access controls, right? I have access to everything. You only have access to your records. I have access to you all. Right? Whatever. You know, that type of thing. That's a specialized user account. We want to keep track of those things. Any information we want to keep and reuse needs to be in the database, right? Persistence. Things we want to remember, store in a database. Yes. I once had the last page visited was something I had we actually kept in a database for supervisor records for this Navy database that I was working on. So that we actually kept whatever page they were most recently on, so that when they came back to whatever they were doing, ta-da, they'd log in and it would take them to the page they were last on. I know it's not sexy, but that's a thing that you can do. Yes. Organizing database into tables. Database normalization is beyond the scope of this course. What I'm going to suggest you do from an organization perspective is keep it freaking simple. There's no reason to overcomplicate things. If you feel like, wait, this is getting out of hand, come see me. I'll help you figure out whatever it is. You should have a list of data items that you want to store, whether it's blog posts, whether it's appointments, whatever. And then a secondary table of user accounts of some variety. Going beyond that, you're overcomplicating your life. Yes? Just stick with the hamburger, right? Bun, burger, bun, boom. Right? Order the good burger with nothing on it. That's what you ordered. I can't do it. I can't do his voice. I'm trying to think of the name of the guy's names. Keenan, no. That's the guy he stars in that movie. Oh well, I'll think about it later. They did another Netflix, not Netflix. Keenan Thompson, I thought his name was. He was an SNL character for a while. I think of it. I'll think of it later. Anyway, the point I was going to make is Kel. Yes, Kel is the guy's name I'm thinking of. Kel is the guy with the good burger. And he tells the guy, you ordered it, but he said, I wanted a good burger with nothing on it. And he's just, but it's just 2 buns. That's what you ordered, just 2 buns. And I don't know where his accent is, but it's hysterical. But good burger. And then Keenan and Kel made their own movie, Netflix special. And then there was another Nickelodeon special. And then there was another thing that they were both in. The kid was very into Keenan and Kel. So anyway, we're only going to basically discuss the basic explanation of optimality. Not really. No, we're not really going to talk about normalization in any form. How do we organize in the most efficient way? We're going to just keep it simple. If you keep it simple, there's no reason to do normalization. Does that make sense? Normalization is talking about how to optimally organize your tables. So we don't need what's called. So what information is necessary to store fields? For each piece of information, we just need to know what type it is. Type is going to be very important. Databases need to know how to store things, so they need to know what their types are. We need to categorize information into groups that make sort of sense. For each category, we identify the distinguishing feature of each category from the data items in it. This is going to form our basis for primary keys. 100% of the time, just use a frickin' ID. Wait, I can do that? Why not? Imagine you're creating blog posts, right? You could put the date and the blogger and the time as your primary key. You could, right? But now all of a sudden, you got to attach all those things to comments as an example, right? If you just give it an ID, now you can store the ID with the comments. You can put an ID on anything, right? Simplify your lives and use IDs a lot. Once your tables are created, decide how the tables are related and form relationships as necessary. These are how we create our relationships. So we're going to have a list of data items, and then we're going to have some other thing like users that are going to be responsible for some of those. So our primary table is going to have keys that attach to the primary key of this other table. And that's it. Most of you will do something like that. Some rules: eliminate non-scalar data. Vector data or repeating data. If you have repeating data in a row, in a record, you probably are thinking you probably have an extra table. Yes? So probably not important. Eliminate data not directly located to key. Any information that cannot be derived from the primary key is better stored in another table. You go, wait, what? So what do you mean? Well, when we have records, we might have data that's not related to the primary key that we're just storing in the database. But why store it? Right? If it's not necessary or not related to that record, it either goes somewhere else or it goes off the table completely. We don't need to store it. Use foreign keys for unrelated data. Unrelated data, we move into a separate table, and that's where we store that stuff. Yay! So data types, numeric, dates, strings, and others. We are going to avoid others like the plague, right? Could you? Yes. I've seen people use images and have images being stored in a database. 99% of the time, that is beyond the scope of necessary in this course and just not even that interesting. Most of us will deal with numeric and string data. Very few of you will want to play with dates. Dates are a pain in the ass. They're not that hard if you use Java. But dates are kind of a pain in general. They just are. And you go, why is that? Formats, 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 formats. Okay. String numeric types, we have char. Char is a fixed length string. That means you have to specify a special length of the string. Varchar is probably what you want, and it'll store a variable character length string. Most of you will use varchar when you need a string. Varchar lets us set a max without worrying about inserting in the entire thing every time, which is much easier. So that's why most of us usually use varchar. Numeric data types, integer, big int, small int, blah, blah, blah. Most of you are going to use integer when you need to use a number, a counting number. Yes? And then you have decimal, float, and double. Almost 100% of you are going to use decimal. Yes. By the way, do y'all know, I mean, you might not know, but y'all know the difference between decimal and floating points? Floating point uses the IEEE 780, 754. You might remember from 261. Uses special data to store an approximation of the number. Decimal actually stores it in a completely different way, and it's designed to be precise, usually for financial applications. Most of you will use decimal though, going back to date. Java SQL date is the one you'll be using. Time of day is time. Both of those is timestamp. I'm going to point out that none of it matters. Use dates if you want to use dates. Don't use dates. You don't want to use dates. I probably will avoid dates. Not because they're hard, just because I got to cut something, and that's something I'm going to cut. Right? They're not hard, and there are millions of examples. So if you choose to want to use dates, trust me, it's easy. You just need to learn how to use the format string. All right, structured query language is a standard language for accessing and manipulating database systems. SQL statements are used to retrieve them. It requires two parts, DDL and a DML. DML is the manipulation language, is so we have mechanisms to create things or for deleting records. And then data definition label is how we create, edit, and delete tables. The DML is for manipulating the data in the tables. Although we discuss SQL queries, we're going to keep things very general. Having said that, there are lots of tutorials. Keep it simple. I cannot emphasize this enough. There is an entire class, CST 333, that you can learn more about SQL in. What should you do in this class? Keep it simple, right? I would throw the other S on there, but I don't want to call you stupid to your face. To your face. Doesn't mean I won't call you stupid, not to your, no. All right, bad joke. All right. And data definition language, creating, deleting tables. Actually built in the DDL is the DML, by the way. Inserting data and retrieving data and editing, deleting data. Most of what we need to do for creating, deleting tables is this freaking simple. Do not complicate it. Create table. Give it a table name. Open parentheses, close parentheses. And then you have a column name, followed by a column type, and then you have attributes if necessary. Only a few attributes we even have to care about. Primary key, unique, if we care about unique, not null, those type of things. Yes? But that's it. Oh, and that columns are separated by commas. So column attributes we might care about is not null. Avoid default values. Hold on a second. Avoid default values. There's no good use for it, and you'll be complicating your work. Because when you start using default values, then when you go to insert it, you don't need to have that. So it screws with your insert things. Easier to leave that off completely, okay? Generated always is essentially auto increment. Avoid that too. Because what you'll essentially try to do it is use it for a primary key and then, oops, it won't work the way you want it to work. Yes? Unique specifies that duplicate values are not permitted. Primary key specifies this comment is unique, not null, and will serve as primary key. This one we're going to use, this bottom one. Null, not null is important, and we're going to use that one a lot as well. Unique, we rarely use. Unique, we rarely use because we use primary key when we need to specify something as a primary key. Rarely do we need to specify something unique, right? It's just uncommon. So here's a create table students, SID integer primary key. This is specifying a field, SID, field name is SID. SID is the integer, and it's a primary key. So it has to be not null and unique. For every record, there's going to be an SID, which is going to be an integer for every record. Then we have a name, which is going to be a varchar, which means a variable character, up to 50 characters in length. Bang. And then we have a GPA, which is going to be a double. Note, there's no comma after the last element. No comma after the last element. You don't need it. Okay? So you shouldn't have it there. This creates a students table with an SID name and a GPA. So if you have more than one, you can specify on a field by a line by itself at the end. You can also specify primary key on a line by itself on at the end as well. So if you choose not to say SID integer primary key, you can just say SID integer comma, and at the end specify primary key SID. If you have multiple ones, you say press primary key and then multiple. You should never have multiple. In this class, just to be really honest, like if we did the appointment thing, like we said, date, time, person, that essentially the three of those together could uniquely identify every appointment in your calendar, right? Assuming that we don't double book. Chatted for like 30 minutes the other day. I'm trying to remember her name. Nathan, yes. Remember your last name, right? But your first name is like beyond me. Anyway, so Nathan, right? Assuming we don't give Nathan two places to be at the same time, it uniquely identifies an appointment. But we know that's a pain in the ass, so we just do an ID, right? Always do that, okay? There's no good excuse for using multiple. In this class, there's just no good excuse for it. You're gonna just complicate your life. 2 seconds it took you to create an ID. 2 seconds it'll take you. It'll save you more time later on. To specify a foreign key, this is important. You can specify a line by yourself at the end. Foreign key field, that's the field that it references, or excuse me, that's the field of interest in the table you are creating. References table name, so the table, followed by the column name in that table. Create table schools, SCID integer primary key. Create table students, SCID integer, right? Primary key. Why did I do SID name? Oh, that's stupid. Should have just used SID, but whatever. See the foreign key? SCID. It's referencing this. And it's saying references schools, this table's SCID. Okay, pretty simple. You'll see lots of examples of me doing this throughout class. So if it's confusing, let me know. But that's what you're doing. You're connecting this table, SCID, to this one. Yes. Side note of this, that means that an SID here must be present here. Right? You can't create an O2 example and there's no O2 in its schools table, right? It references it, so it has to be in that table. Yes. Delete a table is easy, maybe too easy. Drop table, given the table name. That's it. That's it, and it's gone. All the data in the table, gone, column. Write those around, see? The syntax for inserting data into a database is very simple. Remember, if we avoid default, if we avoid certain things, we can just insert into table name values, open parentheses, and go record by record. So SID and name, SCID and name would fill up a schools table. Yes? And you have the values. That's it. And you go, wait a second, it can't be that easy. Why would it be hard? Got one little caveat, because you know there's a caveat, right? When you have a string like bar car, it has to be in single quotes. If it's a number, it just has to be there. But if it's a string, it has to be in single quotes. Otherwise, it won't work. You'll see me have trouble with that later. SQL statement was derived from these basic needs. What, where, and in what condition, right? So what columns? For every time you retrieve data, you're going to specify a column. You're going to specify a location. And then you may or may not specify which rows, right? Maybe you want a condition, right? I want all students with GPAs less than 3 and major equals CS, right? Those are conditions. But I have to say what columns from what table. That has to be part of the table, right? If I just say which columns, I want all the names and SIDs from the students table. That's a minimum information necessary for a query, and it will give me all the SIDs and names in the table, right? Yes, yes. Most retrievals will follow the similar syntax. There are a couple exceptions, join and ordering. We'll talk a little bit about those. Well, we have 2 tables and we have information in 2 tables that we want. We'll need to join those. You'll see me do examples later on. Right now, let's not talk about it. So let's look at a SQL selection statement. Select column number, comma, column number, so we're done with all our column numbers. You can also use asterisk to indicate all the columns, right? All of them. Poor Andrea. Today's not Andrea's day. Just because I remembered her name is Drea. Didn't please her, whatever. Anyway, so you select the column names and then you specify which tables. From, so select, column, separated by commas. No spaces, by the way, that's important. And then space from, and then you specify the table. Most of you are going to have how many tables? 1. Yes? Where? And if you have a where clause, that means you're going to have a set of conditions. Yes? I think we have some basics. The optional where clause allows you to select which rows in the table of interest. So I'm looking for a car. Right? So where column name operator value. So equals, not equals, that not equals is this guy, is the diamond. Less than, greater than equal, like is null. So select asterisk from employees where salary is greater than or equal to 50,000. Yes? That's it. Yay. What does that mean? I'm going to select all the columns from the employees table where the salary in the salary column, the value in the salary column is greater than or equal to 50,000. That's all that means, right? So if my search for cars, select star from cars where Oh, what's the difference between a make and a model? Make, it's a type of car, Volkswagen, right? Where make equals Volkswagen, model equals new Beetle, right? And price is under whatever, right? I'm not gonna tell you how much my budget is. It's embarrassing. Let's talk about like syntax, right? Like. The like operator combined with a wildcard character can create powerful text-based queries. Like means not exactly. Similar to, yes? So the parentheses or the percentage sign matches any number of missing characters, but that means we can use it in a query for a string like this. Select uname from users where name like mi percentage sign. That means Michael, Mike, Michelle, all would fit. Yes? Michelangelo. Trying to think of other.
Yeah.
Mia, there, that's even better. I'm playing a video game right now where there's a character called Mio. Is there an asterisk? Is it really Mia and I just can't see it? No, I think it's Mio. I'm playing Xenoblade Chronicles 3, and I think it's Mio. Anyway, yeah, perfect. Mario. No, not Mario. Mila is another example, okay? Anyway, select uname from users where name like percentage sign M, percentage sign close, right? So what does that look like? What about Michelangelo? Matches no characters, right? Nobody's going to argue with me there. No, nobody argues. Michelangelo, assuming the M is the first character and that one's capitalized, would that match? Nope. So it wouldn't match. Wouldn't match Mike, Mio, Ela, Mia, Mio. Any of those. Mark. Would it match Ramjack? Yes. The M has to be there, but because we assume that the first letter of the name is capitalized. Like for instance, Trisha, right? If we're looking for T, the big T, the T in her name is at the beginning of her name, right? But if it's Patricia, like with a friend that I had when I was a kid, it was Patricia. If we're looking for a lowercase t, that matches. Patrick, right? That matches. But because we assume the first letter is capitalized, that would not match. Yes?
Is it case sensitive?
It is, yes. Select uname for where M, parentheses. That is going to find anything that starts with M and goes over. So moon, milk, whatever, those are all okay. Right? Names might not match because Michael, Mike might be uppercase. Yes? But that allows us to place where the variable is. Also, I want to point out that yes, they're case sensitive. But they're also match before, match after 0 or more. Yes. So, for instance, if my character was Moon, Moon, right, all lowercase, both the first one or the second one and the third one would both match. You go, wait a second, it's not at the beginning. Yes, but that percentage sign matches 0 or more. Yes. Now, what would I do if I needed it to be case sensitive, not case sensitive? I would do like one with lowercase and then or with the other case. Multiple conditions, you have and or, you just put the conditions, you put an and between them if you want them both to count, and or if you want them either one to count. And you can put parentheses around them to get complicated. But what should you not do? On Andrew today, because Andrew's making these faces at me.
It's just my face.
No, I'm joking. Yeah, no, I'm joking. What did we say? Resting, not believe me face. But no, what I was going to say is that, yeah, we can get complicated, but we really don't wish to get complicated. What happens when things get complicated? What happens when life gets complicated? Do things go well for us when life is complicated? So Riley's gifted. So it's complicated for him and it just works out. Complicated for me is complicated for me usually means I get SOL, right? But the point is, we keep it simple, keep it straightforward, and keep it in front of you. It's the football term, right? Keep it in front of you, and it's easy, right? Like when you make a mistake, it's usually very easily representable. Like this, is what's wrong. You send me an email, and I'll send. Did you mean to say? And I'll just write your query in words. Did you mean to say this? And you're like, oh no, of course not. Right? So keep it simple, but and or. Multiple tables, sometimes we need data found in more than one table. Avoid this right now, but you can just do a SQL statement. Select employee.address, branch.address. We identify the table dot field. And then we have from employee comma branch, where we have two tables. So when you have a user table and you have a data table, for example, you may need data from both, right? So select all the students that belong to so-and-so, as an example. And you have to match something. So where employee.branch ID equals branch.branch ID. So you want to match those two tables. Where do they match up? You need to specify where they match up. Okay. There's a word for that though. When you have a referenced ID, when you have a foreign key, you can use a join, call it inner join, select blank list of columns from table 1, inner join table 2, and it'll do that matching for you. You just specify which field you want to specify on table 1 dot key field equals table 2 dot key field. It's usually pretty simple. You're going to see me do this when we do our example portion, but keep this simple. Do not overuse this. Yes? Sort and retrieve data. Sometimes you want data retrieved to be sorted using one of the fields. You can just add at the end of the query, order by field name, descending and ascending. You can also put them in comma. So order by, say, students, right? So I want to order by GPA, comma, last name, right? I have to put the descending and ascending on each of those though. But do you know what I mean? Like, so I want to sort by a GPA ascending. So that means the lowest GPAs come first, right? It ascends. And then if they're equal, the comma, if they're equal, it's going to match on last name. And so maybe I want that to be descent, but you have to do that on both. You'll see me do an example, but keep it simple. It's like a trombone got run over. All right, update is simple. Update table name, set column equals value. So you can specify all the columns if you want, or you specify a single column, whatever you want, where condition. Earlier when when we were talking about queries, you had me say where if you want a condition, right? On an update, if you don't specify a condition, it'll update every single column that if you specify name equals Riley, and without a where clause, in the student table, it'll update every record in the student table named to Riley. Probably not what you want. Yes? So you probably want the where condition. That's why it says be very careful. Why? Changing data is not undoable, right? What do you mean undoable? So you know how like when you screw something up in Excel and you just hit the undo button, and it magically unfucks you? It's a nice word to say it, right? Guess what happens in database world? You delete some data, you change some data. In the real world, that's the case too. There's not always a backup for super simple things like this. Like for instance, you do this in production as an example. You change everybody's balance to $3. There were tables, there were changes made to the table between 9 o'clock and noon, whenever you decided to be stupid, right? So how do you make it go back to that? Good luck. Somebody else will probably be doing it though. I'm not joking. You would get fired. This is something that they would fire you for. And so when you're in production, you're gonna be amazingly careful in a way that like you don't do it in test, right? So, but the point is that you would probably need to go take your journaling information, which none of you care about. This isn't a database class. It is possible to recover, but you would not want to do it. Okay. But anyway, the point is be very careful when you do this. Okay. Deleting data from the table name uses retrieving syntax. So delete from table name where conditions. Guess what you should do when you do this? Be very, very careful. Remember when you drop table, right? Drop table and give it the name and it just deletes all the data in the table. Yeah, remember that? So delete from table name, you see that second one? Where it said if I delete from students and I just don't add a where clause, what happens? Table remains, it's not dropping the table, but it is wiping out all the records in the table. Boom, boom. Okay. You're like, no way, that can't happen. They can't fire me for simple mistakes. Yeah, they can. Yes, they can. Anyway, we discussed motivation for just avoiding databases. Good news, bad news. You can't avoid databases in the real world. They're just ever present, omnipresent, if you will. Too much data. Really, there's really too much data to be interact with to just not have it. We talked about several database management concepts and primarily relationship database management systems. I have hair in my mouth. I hate that. Tables, relationship, and use. Keep databases simple. If you don't keep them simple, all hell breaks loose very, very quickly, right? So for those of you who don't know, I learned to sail this summer. And there are lots of different knots you have to tie, lots of different ropes going all over the place, right? A rigging kit involves about 6 different ropes of different varieties. How many of those could I go out on the boat with? Or how many of those would I go out on the boat with? And let's suppose that, you know, Riley's messing with me and cuts it down to a thread and it goes out. What would happen? All hell would break loose. Doesn't matter which one you cut out. Some would be easier to fix than others, right? Just make the rope a little shorter and you're fine, right? Other things are pretty important, like one of the ropes keeps the mast in the boat. One of them connects the sail to the boom. So imagine being out there and the sail flapping around in your face, doing this, and you're trying to figure out why the hell the rope is broken. So you got to retie it and very quickly, you get it complicated. All of a sudden, none of the code works. All of a sudden, the data is not doing what it's supposed. Like you can't get it to do what it's supposed to do, and keep it simple. I'm going to do lots of examples in the class, very similar to what you're going to be doing for homework. Almost too similar. Yes, you're just with different data items. Then when we get to our project, what are you going to be like? It's going to be kind of like all of our homeworks put together, except your own data set type thing, right? That's why I'm telling you to keep it simple, right? Things get out of hand very quickly when you get fancy. Yes? And sometimes fancy is good. Sometimes fancy, like create it, like add in a date as an example. It's pretty simple to add a date, honestly. It's a pain in the ass of the format, but it's pretty simple to do so. That's not what I'm talking about. I'm talking about having 6 tables. And your database query is like half the page. You open Notepad and your screen is full of the query, you're doing something wrong. Yes? Having said that, I've had like 15 line, 20 line queries in real life, but I have people chat, hey, can you look at this for me? Right? Can you look at this for me? Right? That's real life, but in this class, keep it simple because we're not trying to go over everything. We discussed design and relational database management systems, explain field data types and their use. Keep it really simple. I'm going to use about decimal. I'm going to use decimal, double, probably primarily, integer always. What's the other one I use quite a bit? Bar. Yay. I won't use the blob. Blob scares me. Just because I get to say the blob scares me, but that's how we store binary data. It's actually called a blob. That's not a joke. I mean, it was kind of a joke saying the blob scares me, but that is a real thing. Yes. Sorry. I have a funny set of stupid, well, let's just say stupid sense of humor. But anyway, we discussed SQL in terms of purpose, use, and we talked about several types of SQL statements. Note, we talked about them. We're going to reinforce them. You're going to see me do them a lot. Next class, for databases, W3 Schools is very good for that. Queries, remember, you should keep it simple. Also, remember I told you about that long query in real life? We can actually tie that to usually database management systems will have a mechanism to log in remotely. We can actually type in the queries or send the query via text and then run it in the database before we put it in our code to verify that at least the query is going to do what it's supposed to do, right? Because trying it out in code is sometimes the wrong way to go. But the point is W3 Schools is great for that. Derby and NetBeans tutorial, we're going to go over that entirely next class. But I want to talk about one other thing really quickly. I didn't mention this before, but every now and again, due to life happening, I may need to record a session here and there. And right now, I don't foresee any recording necessary except for one. And I do want to talk about this. There's going to be one that everyone is going to want to record. This is a Monday, Wednesday class. Can anybody think of a Monday that will almost guarantee you want to be recorded? One Monday. Something important happens that week.
Halloween.
No. No. We eat something important. Thanksgiving. There's a Monday, Wednesday class. That Monday is actually class. So that day will most likely be recorded. For those of you that travel or whatever. The recording will be recorded before you would watch it. But I'll let you know in advance. None of anything that's ever recorded, pre-recorded will ever be a surprise. It's not like you walk in and there'll be a note on the board saying it's pre-recorded today. You get a lot of advance notice, but that's one. I think it's 11:21. Almost certain it's 11:21. I'll look up to be sure. But that day is just it's a Monday, and we're traveling to New York. So upstate New York, not New York City. So I gotta go cook a turkey on a smoker, not a fryer.
That's what it is.
It's pretty good. I actually like it better than frying it. Oh. Yes, the 21st. That day will be recorded. Not because I have to, but because it will. Also, my wife wants to go to the wilds. Anybody know what that is? So she wants to go on a 3-day weekend, and this class is over, but I'm just gonna let you guys know. She wants to go to Columbus Zoo, and there's a thing called the Columbus Zoo Wilds. It's a hotel that yeah, I know, I'm sorry. By the way, you gotta get going, right?
No, I thought so.
Okay, because I was gonna say you have a class right afterwards. But there's a place in Columbus Zoo where there's a big Columbus Zoo, and there's a big place like a safari park. And then you can stay among the animals. And so wants to do that.
Wait. Where do you sleep though? You stay in a hotel?
It's literally a hotel because
Okay.
I would have flatly, let's just say unequivocally, flatly refuse to stay in a tent where wildebeest could be.
Isn't it like peaceful? That's the experience.
Unless you're giving me a giant gun and a barbecue pit, I'm good. No, I'm out. I can camp, don't get me wrong, and I've camped in places that other people would be like, you really want to camp here? But like, no, not a wildlife park, dude. And it doesn't have like, don't have like, there's a Disney special about it. Not Disney special, Natural Geographic. You might have seen it, Secrets of the Columbus Zoo. Anyway, they don't have like carnivores roaming the thing, but they have like big goats. What are those big goats called? Szechuans? It looks like Szechuan chicken, like the Chinese, like Chinese food chicken, but it's not. It's like sort of the word, but not. There's like a letter missing, so it's not Szechuan. It's like Sichuan or something. They're giant. They're in the goat family. We can't believe y'all like. Anyway, they're ostriches and big things on this thing. So there's not something I want to go. Yeah, they are. But that's not the problem, right? The problem is I'm not scared of staying around things. Whether bears are or alligators, right? Alligators will stay away from a campfire, generally speaking, right? That doesn't scare me. But like roaming herd animals, I'm out. Chance of a stampede, out. So